Okay, so today's lesson is over graphing equations. So far we have taken an equation, we've determined the slope and the y-intercept. We have taken a table, we've determined the slope and the y-intercept and written the equation. We've taken a graph and we've determined the slope and the y-intercept from that and written the equation. Today we're kind of working backwards. We are going to take the equation and graph it using what I call fast graphing. I've got several examples here, and the first thing I want you to note is the y-intercept, the b. I like to say that stands for begin, okay, because that's where we're going to begin with our graph, okay? Remember, the y-intercept is the point where the line crosses that y-axis. I'm going to highlight all of my y-axes so it's easier to see. Okay? So look, my b is at -5. So look what they did. They went down to the -5 and plotted their first point. We're going to start from there. Okay, now how do you find other points on the line? Well, you start from your y-intercept and then you use your slope. Remember, slope is rise over run. You've heard us say that a lot. And here, my rise is 3, my run is 4. So from this point, I'm going to rise 3, 1, 2, 3, and run 4, 1, 2, 3, 4. And that's where they got that point right there. And you can do it from all points on the line. From here, I can rise 3, 1, 2, 3. It's very hard to see with my eyes. 3, and run 4, 1, 2, 3, 4, and I landed on the line. See it? Okay, look at this example. They started at the 7, right? This is a negative slope, so look what my finger's doing. If I follow it from left to right, my finger's going down. So I should, from here, go down 2 units and over 1, down 2 units and over 1. Down 2 units and over 1. See how I'm landing on that line every time? That's how you get more points on your line. Okay? Ooh, look at this one, y equals 2. So this one looks weird. I see a 2 is my constant. Remember, that's my y-intercept. Okay? See how they've got the line crossing at the 2? But look, there's no mx, there's no slope. So look what it says, m equals 0. It's like this, y equals 0x plus 2. But 0 times x is just 0. So that's where they get the y equals 2. Alright, so there's no rise here. So if there's no rise, that means I don't go up. So it's all of these points along this horizontal line. Remember how we learned last week with Slope Guy that a horizontal line has 0 slope? 0 slope. Okay? And then we've got this undefined line, right, where it says x equals 3. So do you see how this line isn't touching the y-axis at all? It's touching the 3 on the x-axis. So every single x value here is 3. No matter where I go on this line, every single x value is going to be 3. So that's why it says here it's a vertical line through the 3 on the x-axis. Okay? All right. So let's do some fast graphing. Okay? This is starting at the 5, right? B for begin. So I'm going to go up to the positive 5. 1, 2, 3, 4, 5. It starts right there. Okay? It's a negative slope. So from there I need to go down 2 units. Down 2, and then I need to run 3. 1, 2, 3. Down 2 and run 3. 1, 2, 3. down 2, and run 3. 1, 2, 3. And you can see those are falling on a straight line. There's my line. Fast graph. Much quicker than doing input and output and plotting all those coordinate pairs. Okay? Look at number 2, y equals 8. Okay? We said on this page, when you see something like that, it's a horizontal line, right? And my y-intercept actually is 8, so I'm going to go to the 8. 1, 2, 3, 4, 5, 6, 7, right there. And it's got 0 slope. There is no x. 0 slope, so I'm going to, shouldn't say there's no x, there's no slope, excuse me. It's a horizontal line through that 8. Every single point on this line has a y value of 8. Every single point is 8 units above 0. Y equals 8. This is a 0 slope. And notice here, we said that the slope is negative, and if I follow my line from left to right, it is going down the graph. Okay? I'll just draw a slope guy up here to help us out and make sure that we're on the right track. Okay? Let's look at number 3. Y equals 4x minus 2. B for begin. I'm going to start at the negative 2, and I'm going to plot that on the y-axis right there. Alright? Now, remember, a slope is rise over run. I don't see a number on the bottom. My rise is 4, but what do I assume is down here if I don't see it? There's a 1 there if I don't see it. So it's 4 over 1. So from this point, I'm going to rise 4. 1, 2, 3, 4, and run 1. I'm going to rise 4. 1, 2, 3, 4, and run 1. 1, 2, 3, 4, and run 1. And then connect my points. And there's my line. A couple things I want to point out. Notice our slope was positive. If I go from left to right, my finger is going up the graph, right? Another thing that we haven't talked about much, the bigger the slope, the steeper the line. See how this is a whole number slope, and it's a very, very steep line? Okay, look up here. It's a fractional slope. It's going down, but it's fractional. See how it's not nearly as steep as this line was? So the bigger this number, and by bigger I mean positive or negative, the steeper the line is. Okay. Number 4. B for begin. I'm going to begin at that negative 1 on my y-axis. Okay, and then I've got a slope of 2/3, so that means I'm going to rise 2, 1, 2, and run 3. 1, 2, 3. Rise 2, 1, 2, and run 3. 1, 2, 3. Rise 2 and run 3. 1, 2, 3. Okay, connect the points. Oops. And there's my line. It's a little crooked. Human error, sorry. But if I follow my line from left to right, my finger is going up. So that's good. It's a positive slope. But look how steep. See how these are about the same in terms of steepness? This is a positive 2/3 and this is a negative 2/3. The grade of it is about the same. Well, it is the same. They're just going, one's going up, one's going down. Okay? Alright, x equals 7. My front page told me If I get something like that, it's going to be a vertical line through that 7 on the x-axis. So x equals 7, so I go to 7 on the x-axis. 1, 2, 3, 4, 5, 6, 7. And it's going to be that vertical line through that 7. And this is an undefined slope, right? The U, the tip of his nose, stands for undefined. It's an undefined slope. All right, and number 6. I'm starting at the 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you know what I'm going to do for this one? I'm going to go by 2s because I'm falling off the graph. You don't have to. We could estimate, I guess. I guess I could estimate. No, I'm going to go by 2s. I'm going to go 2, 4, 6, 8, 10, 12. Okay, I went by 2s. 2, 4, 6, 8, 10, 12. I see a negative slope, so that means I'm going to go down. And I don't see a run. -6, I'm going to assume my run is 1. The other thing that I needed to tell you, should have already told you probably, is negative tells you whether or not to go up or down. You always run to the right. Just keeps things simpler that way. Always run to the right. Okay? The negative tells you whether to go up or down. Negative, you go down. Positive, you go up. Okay? So, from this point, from my starting point, I'm going to go down 6 units. Remember, we're going by 2s. So 2, 4, 6, and over 1, so that's only halfway in between. Alright? Another one. 2, 4, 6, halfway. 2, 4, 6, halfway. 2, 4, 6, halfway. So those halves kind of make it a little harder. But look how big this 6 is. This is going to be a really steep line. Remember, the bigger the slope, the steeper the line. So see how steep this is? It's because it's got a -6 slope. If I follow the line with my finger from left to right, it is going down, negative, right? And all of these are, well, this one and this one's non-proportional, right? Non-proportional, because they don't go through the origin. Non-proportional, they don't go through the origin. Okay? And that is it. Good luck on your independent practice.